CGI-IUGS. Thank you very much indeed.
Thank you, Chair. Thank you all very much for this Wuhan event of the TC211. I have learned huge from you. So I will report our work, some of our work to you on the standards which we have developed for decades, and also implementation globally. I will see two parts. One is the CGI-IUGS Geosciences standards, what are our key standards, and then the DDE, Deep Time Digital Earth program, our standard work. You may know geoinformatics, you all know is on the ground, or a little bit underground, but geology is deep in the ground. Maybe deep. Yeah. So what is CGI-IUGS? IUGS is the International Union of Geological Sciences. It has 7 scientific communities, and CGI is one of it. CGI is on behalf of IUGS dealing with geoinformation issues. You can see this more tension or more issues are going to geoinformation in recent years because of all the digital transition, AI, any activities of human are related with digital, with standard, I can see. CGI, this is our web page. CGI, our mission is to foster interoperability of all the information of science, of course, mostly geoscience information by active community leadership, and also collaboration, education, all activities to also provide the best practice for the geoscience communities. Our vision and our new strategy plan 2024-2028, the governance vocabularies. Vocabulary is still very important so far, not only for the semantically for interoperability, and also for AI, and also data models, artificial intelligence, 3D. We have done a lot of 3D because the deep earth. Also our communications workforces and also groups. We have several currently, we can say, important working groups or projects. One is the DDE standard group. We are now collaborating with other like ASC, it's code data for the standard work, and also the second one is Earth Resource ML. This one is focused on minerals from the exploration to the recycling, all the whole process of the mineral standards. And third one is Geoscience ML. Geoscience ML is a model for geological sciences for data management, and the geoscience terminology also. The terminology has supporting all the standards in semantic. And we have a collaboration with OGC, a working group called Geoscience Domain Working Group. This try to harmonize or to incorporate our data with other industries, with like buildings, city plans, kind of things. And we have also collaborated with some very new organizations on the ontology, on the knowledge graph, exactly. Yes, the standards, I will not say too much, just already show you. All the standards are widely adopted by the nations, communities, Geoscience ML, groundwater ML, and borehole. Exactly. So I will say a little bit of our standards. Geoscience ML, it covers, you can see the disciplinaries, including geological unit, maybe to specify for you geological structure, age, earth materials, boreholes, fossils, rock properties, geomorphology, alteration kind of thing, of course, including geochemistry for the chemical composition, and also sampling. This is the packages or the UML. And we go to the structures of different geological features and include all the attributes. There's a huge book of this. And the Earth resource map just we extend the geological features to the Earth resource. This is coping with the minerals from exploration to the mining to industry to the recycling even. You can see this is an example for all the mineral system from the very beginning occurrence, exploration to mining to products for all the things. This is quite useful nowadays because we are less of resources for our faster, rapid development. For the search terminology, we have a group. This group has the longest group for this because for like Geosciences ML have already muted and implemented and we just maintenance. But for the terminology, we are still working hard for it because a lot of new terms, a lot of new even some methodologies for this. And for groundwater, quite importantly, in Africa, we have these standards because geology, the groundwater comes from hydrogeology. The hydrogeology unit is the same with geology. It's it's a little bit easier for geologists to do it, but it mainly concern about the hydrogeological units and void flow bodies, fluid flow, and wells. Those things would define all this application for the human to using the underground water. And this one, Geosciences domain working group, you can see just with OGC, we have set up this in 2017. We have working by a leader in BRGM, by scientist Mike Boffey. We have exchanged or discussed with the data model on agriculture, on city plan, especially for the beam standards, and with hydrogeology. All this is still going on. We have done two projects. One is the borehole interoperable experiment, and also geotech, because different industries have different borehole, but this structure is quite different. So to use, I mean, for the fair data principle, for data interoperable, we must have a common model for this. So this some of our work have been done for mapping all the different models to be used by different industries, different governance. And implementation of our standards in One Geology, we know, was initiated by a British Geological Survey, and globally more than 120 countries joined this to release the data. They used our standard Geosciences ML to harmonize. Just can be to search the data on one screen on one portal, and also is there used our Geosciences ML for managing geological data, and also Austin and USGen for all this information releasing with the standard using our standard for data release, and also the DDE. This shows the DDE has used all the different time for our standard have been used different time for some. If there is some global initiative, you can see a peak using our standards. And this is just pictures of the one geology, and a lot of they use it. One important thing is the activities. They have adopted our standard for geological data for the common server. So second one is the DDE, what I did a very ambitious international program. They try to harmonize global deep time Earth data and share global geoscience knowledges. The vision is to transform Earth science, actually geoscience, not Earth science. It was kicked off in 2019, and all this activity include different disciplinaries of domains globally. And our CGI from IUGS was asked to join to set up a standard group because the DD want to harness the data to data-driven paradigm for the future. So the standard is very critical. So we are asked to, we were asked with the co-data to set up the group. Our mission, I mean, standard group is to implement international standards, ISO standards, OGC standards, of course, or CGI standards to DD scientists to data-driven diagram in the future. The DD program is at the very beginning in 8 years, but now it becoming 10 years. It's still ongoing. One case we have used ISO standards 19115-1 and to develop our DD geoscience method standard because we have checked all the standards, but not efficient for our geoscience to be used. Like we have geological history back to millions of years ago. Now we have disciplinaries in geoscience. We can see more than 20 or 30 disciplinaries. We have to extend the topic category of ISO. ISO only have one topic category called geoscientific information. So, and also other issues. So we have based on ISO 19115, Dublin Core, and OGC CSW, and also other standards to get we call it a simple, efficient, and also machine readable. This is maybe in geoscience, maybe the first one for machine actionable. We have equipped the ISO, the topic category to 41 right now. This is the code list. We have some. Of course, we have we have selected only geoscience related packages from ISO 19115 and extend to our demands. This is on the left is the annual 114 is the topic categories. We have the second second grade to 40, and we have added one we call data science as one topic category. We have also defined a service type code. We have a lot of audits, even in the one ISO standards, there's no type code. So in this program, it was designed to use this. We also get some accuracy in code list. This is just an example of how geoscience information standard be issued to meet the demands of the geoscientist communities. We have gathered in Suzhou, also a beautiful city of China. The first after COVID, in-person meeting on future geoscience information standards. We have discussed all these things. Then we released these standards for DDE, not only for DDE, but also for global geoscience community to be used these standards. With Steve Richard from Arizona has also coding the app based on geo network. So these standards can be used and also can be harvested with other standards for metadata that will be benefit the DD or the benefit others for international data, findable, accessible, interoperable, and reusable. So thank you very much.
Thank you very much indeed. I'm not a geologist myself, but I know there's one in the room who was taking all that in and lapping it all up. So thank you very much. It's good to see that the world of standards in geology is alive and kicking and actually facing a lot of the same challenges that we do. So we do enjoy working with our colleagues that work with geology. Okay, does anyone have any questions at all? Stop, got a question. It's all there, okay. No questions at all? Okay then.